Good morning, one and all. Today we are going to discuss about computer organization and design. So, in the place of computer organization, all of you know how to organize a computer with the help of using different devices and how the designs are made in this part. So there are different parts are there. Actually, computer consists of three parts: input unit, central processing unit, and output unit. The purpose of input unit is to access the data. In meantime, the output unit is we can get the result. We can see the result with the different output devices. In between these two, we have central processing unit. In the place of central processing unit, there are three types of other parts are there. They are control unit, memory unit, and arithmetic logical unit. Control unit, which is used to transfer all the information appropriate places as per the instructions are received. Like that, memory unit, this unit which is used to store all the information temporarily for the purpose of execution. And then central processing unit is a main unit which will do all the operation in the computer organization. In the place control processing unit or central processing unit are almost the same. It consists of general register organization, stock organization, instruction formats, addressing modes, data transfer and manipulation, program control, RISC and CISC operations. So as we discussed earlier in various places regarding general register organization, so number of registers are there. Registers is nothing but a storage devices. It is in a memory locations, it is in a buffer location. The informations are stored temporarily in the place of control processing unit. So number of general registers and organization are available. There are 8 types of general register organizations are there. And then stack organization, this is an organization which is used to store the information in a stack method. The operation of stack is LIFO, last in first. And then instruction format, each instruction it must have certain formats are there, 16-bit formats, so something like that. In that format, address instruction mode, instruction type and instruction addresses are mentioned as per the size of the instructions. And then addressing modes are there. Addressing modes, there are number of addressing modes: direct addressing, indirect addressing, relative addressing, index addressing, increment, decrement addressing. Number of addressing modes are there. And then followed by this case, next data transfer and manipulations. So without data transfer can't do anything. Number of ways in which the data can transfer among the devices, among the computers. So if you enter the data in enter the information in your keyboard, the information can transfer to central processing unit, control unit. Control unit will be transferred as per the instructions received. So all these things are transferred through different wires, and then based on the transferred data, the process takes place, executions takes place, or manipulations takes place. And then control program which is used to control all the program, as we discussed earlier in our earlier multiplexer and demultiplexer. Number of control units are there. Likewise, the last one, RISC and CISC, reduced instruction set computing and complex instruction set computing. So now we move on, especially in the place we are going to discuss about data transfer and manipulations. Among these cases, Mainly we are going to discuss about data transfer and manipulations. That means, as I already mentioned, that how the data can transfer among the devices. Number of devices are available in your digital computer. So how the data are transferred and manipulations. Instruction set of different computers, different from each other, mostly in ways the operands are determined from the address and mode fields. The basic set of operations available in a typical computers are data transfer instruction, data manipulation instructions, program control instructions. The first one, data transfer, which is used to transfer the data from various places. The transferred informations can be do some executions, some calculation or process that could be takes place in our second part, perform arithmetic, logic and shift operations. And then last one, program control instructions, decision making capabilities, change the path taken by the program when executed in computers. So followed by the above three cases, first we have discussed about data transfer instructions. Transfer means move from one place in computer to another without changing the data content. Most common transfer: processing, register memory, processor register memory, processor register input output between processor register themselves. The typical data transfer instruction: load the mnemonic codes, that is the symbolic codes. LD means load, ST means store, MVV move means move, exchange XCH, input IN, output out, push, pop. The last two cases are used in the place of stack. And apart from that, some assembly language convention modify the mnemonic symbols to differentiate between the different addressing modes. The data transfer instruction with the different addressing modes are, as I already mentioned, that instruction format is there, addressing modes are there, depends on the cases it can be able to execute. So the data transfer instruction with the different addressing modes. So number of addressing modes I mentioned earlier. These are the modes are available: direct mode, indirect mode, relative mode, immediate operand mode, indexed addressing, register indirect, auto increment, auto decrement. The corresponding convention: LD for load, these are the load operations. ADR address, the corresponding example is memory of address transferred to accumulator. AC means accumulator. Accumulator is in a processor register. All the operations are takes place in the place of AC. AC is an accumulator. LD is at ADR. It consists of, so already AD is in a memory, and then memory contains another memory. That's why it mentioned M into memory of ADR transfer to address. And then LD string operator, that is memory of some operators are available. Here they can be able to consider program counter plus ADR for relative address. So like that, so many addressing modes are available. Apart from that, data manipulation instruction. These instructions perform operations data and provide the computational capabilities of the computer. There are three basic types: arithmetic instructions, logical and bit manipulation instructions, and shift instructions. In the place of manipulations, arithmetic instruction, only arithmetic operators are considered. Logical, bit and bit manipulation instructions, only logical and bit manipulation instructions are considered. Shift, move from one place to the another place. These are the example for arithmetic, logical and shift operations. And then, so these are logical bit manipulation operations are considered. and then this is a shift operation, shift left, shift right, arithmetic shift right, and then program control instructions. Program control instruction can take place with the help of using jump, branch, skip, call, return, compare, test. So this is an example for this case. And then apart from that, some other status words are there. Status words are C, carry, S, sign, eject, and V. So okay, these are the process are considered in your data transfer and manipulations. Thank you very much for watching this video. Thank you.